All right, so number 28, it says we're given g of x, which is a piecewise function, and it wants us to find where g of x is discontinuous. And then in part B, it wants us to find on what interval is g of x continuous. All right, so we do that at the same time, basically. So the questionable spots where this function is continuing is where it may or may not be piecing together over here. So we start off by assuming that it's going to be continuous everywhere, from negative infinity to positive infinity. So that's at an infinite number of places on this interval. But the two places that are in question are going to be -1. So I'm going to check x equals -1 and 3. So I'm going to check x equals 3. And so checking x equals -1, I'm going to check the top equation and the middle equation. So checking the top equation, if I put a -1 in there, there's nowhere to plug the -1 into. So it's automatically going to be -3. For the middle equation, if I put a -1 in right there, I'm going to have 5 times -1 plus 2, which is -5 plus 2, which is -3. These are the same thing. So I get the same thing if I put -1 in the top or middle. That means x equals -1 is continuous. Nothing wrong with it. So then I'm going to check x equals 3. So that means I'm going to check the middle and the bottom equation. So for the middle equation, if I put 3 in for x right here, I'm going to have 5 times 3 plus 2, which is 15 plus 2, which is 17. And then the bottom equation, if I put a 3 in, I'll have 2 times 3 minus 4, which is 6 minus 4, which is 2. 17 and 2 are not the same thing. So this function is not continuous at 3. So for part A, where is it discontinuous? It's discontinuous at x equals 3. Part B, on what interval is it continuous? It's continuous every other value, which there's infinite values, every other value except 3. So I literally just need to pluck 3 out of this interval, and I'll replace it with a union sign. So I'm going to go from -infinity to 3 and not equal it, and then from 3 to infinity. So this is where the function is continuous. All right, 29. We're writing the intervals where the function is continuous. So a function is continuous in the exact same place where the domain exists. To find where the domain exists, you look at 3 issues with the domain. One issue is logarithm. So in problem number 29, we don't have any logarithms to worry about. Another would be even-rooted radicals. We don't have any of those to worry about. And the third place is denominators. We do have a denominator to worry about. So we want to know what's going to make this denominator equal 0. Okay? So we have a choice here in solving. We could add the 4 over and say x squared equals 4. When we take the square root of both sides, you have to remember that when you take the square root of a number, it becomes plus or minus that number. So that would become plus or minus 2. So there are 2 places where this is not continuous. 2 places it is not continuous. So think of your interval going from -infinity to positive infinity, and we are going to pluck out -2 and 2. We're going to take those out of the interval and replace them with a little union sign. So we are going to go from -infinity to -2, then from -2 to 2, and then from 2 to infinity. This is the interval where this function is continuous. We took out the 2 values where it is not continuous. All right, so number 30. Number 30 has a logarithm. And so whatever you're taking the log of has to be greater than 0. So 8 minus 2x has to be greater than 0. I'm going to subtract 8 from both sides, and negative 2x has to be greater than negative 8. I'm about to divide both sides by a negative, so I'm going to go ahead and flip my sign. If I divide both sides by a negative 2, I get x is less than 4. So if we think of a number line going from negative infinity to positive infinity, and 4 is right there, it's pointing in the direction we're going. We're going this way, and it does not equal it. So this is going to be a parenthesis around the 4. So our interval is going to go from negative infinity all the way to 4 and have a parenthesis. Okay. Number 31 does not have a denominator or a logarithm, but it does have an even-rooted radical. So whatever's underneath that even-rooted radical has to be greater than or equal to 0. And I'm going to subtract 12 from both sides, so I get 4x is greater than or equal to negative 12. Divide both sides by 4, and I get x is greater than or equal to negative 3. That's where my function is continuous. So think of an interval from negative infinity to infinity, and we're going to put negative 3 on there. It's pointing in the direction it's going, this way, and it equals. So we're going to have a bracket here. So we're going to have a bracket from negative 3 to infinity. That is where this function is continuous. Number 32. Number 32 does not have a denominator, it does not have a logarithm, and it does not have an even-rooted radical. So it does not have any issues. It is continuous everywhere. Number 33. Number 33 does not have a logarithm, does not have a denominator, and does not have an even-rooted radical. So it does not have any issues. So it is also continuous everywhere. Number 34 has a logarithm. So whatever you're taking the log of has to be greater than 0. So x minus 5 has to be greater than 0. If I add 5 to both sides, I get x has to be greater than 5. So picture a number line, and here's 5. And x has to be greater than 5, so it's pointing in this direction. It's not equal to it, so we're going to have a parenthesis sign there. So we're going to have parentheses 5 to infinity. That is where this function is continuous. Number 35. Number 35 does not have a logarithm, does not have an even-rooted radical, but it does have a denominator. So I'm going to set that denominator equal to 0. So solving for this, it's a quadratic, it's trinomial, so I'm going to factor this. Factors of 2x squared are 2x and x. This sign right here in front of the constant tells me one of my signs is going to be positive and one's negative. And don't know where to put those yet. Factors of 3 are just 1 and 3. And so I don't know if it's going to be 1 here and a 3 there or vice versa. So I'm just going to put the 1 there and the 3 there. I'm not even going to put any pluses or minuses. And I'm going to test this. So remember, when you're testing to see if something factors, you want to FOIL it out, but really you just want to do the middle part. You want to OI right there. So the outside gives me 6x and the inside gives me 1x. And I'm wanting to know if that can somehow become negative 5x. And it can if the negative goes with the 6x. So whatever I multiplied to give me 6x, I'm going to put a negative on and a positive on the other one. So I have this equal to 0. So that means either 2x plus 1 equals 0 or x minus 3 equals 0. Subtract my 1. So 2x equals negative 1. divide by 2, and I get x equals negative half. That's one of the places where this function is discontinuous. The other one, x minus 3 equals 0, so x equals 3. So it is discontinuous at these two values. So I'm going to pluck those two values out of my interval. So my interval is going to go from negative infinity to infinity, but I'm going to take out negative half and 3. And in their place, I'm going to put a union. So I'm going to go from negative infinity to negative half, then again from negative half to 3, and then again from 3 to infinity. This is where my function is continuous. Number 36. Number 36 has two of the three issues. It does not have a logarithm, but it does have an even-rooted radical and a denominator. So for the denominator, x minus 5 equals 0 whenever x equals 5. So that is one place where this function is not continuous. Then we have to deal with this even-rooted radical. So at this top here, x minus 3 has to be greater than or equal to 0. If I add 3 to both sides, I get x has to be greater than or equal to 3. So I've got two things happening here. X has to be greater than or equal to 3, but it cannot be 5. So if I look at a number line that goes from negative infinity to infinity, I'm going to put 3 on there and 5 on there. And x has to be, it's pointing in the direction I'm going, and it equals it. So I'm going to have a bracket there. And I'm going this way, but it's not going to equal 5, but it's going to keep on going. So where that 5 is where I'm going to have a union occur. I'm going to have a bracket from 3 to 5, not equal, and then union with 5 to infinity for that one. Okay, number 37 says find the average rate of change. So average rate of change. Average is algebra. That means between 2 points. And so that's where we just use our basic slope, which is y2 minus y1 over x2 minus x1. And it says on the interval from 0 to 2. So that means we have x equals 0 and we have x equals 2, and we just need to find the y values for those. So if we plug these in, we get 3e to the 0, which you could put in your calculator if you want to. E to the 0 just equals 1. So that's 3 times 1, or 3. And then if you put a 2 in there, we'd have 3e squared. So that one I'm going to plug in. It's going to be a crazy number, but we'll still plug it in anyway. And so we get 3e is over here on the left to the 2. And I'll just do 3 decimal places. So I'll say 22.167. So 22.167. And so my average rate of change is going to be 22.167 minus 3 over 2 minus 0. And so that's going to be 19.167 divided by 2 minus 0 is 2. And so back over here, I did minus 3 on that one. And then I'll do divided by 2. And so my average rate of change is 9.584. And that's if it's rounded. If for some reason it wants it as a perfect number, then our points here, we could just leave them in terms of e. So this one is still going to be 0, 3. But if we left this one in terms of e, it'd be 2. And instead of making it 22.167, we would just leave it 3e squared. And so if we did that and we wanted to find the slope, then we'd have 3e squared minus 3 over 2 minus 0, which the top part doesn't get any better. It's just 3e squared minus 3 over 2. So either one of these is fine. All right, 38. Suppose the total cost in dollars to produce X items is given by this function. Find the average rate of change. That is the slope between 2 points. So that is our basic m equals y2 minus y1 over x2 minus x1. When the number of items produced increases from 200 to 500. So our x values, we have 200 and something, and then we have 500 and something. To find the y values, we're going to plug these x values back into this function right here for x. So since this is a little bit more, so we can just plug them in both to your home screen. Oh, stop that a second. Alrighty. So we could plug them both into our home screen, or we could plug them into our table. It doesn't matter. I'll just do my home screen. 0.0003 parentheses 200 parentheses to the third plus, oops, not up there though, arrow to the right, plus 0.14 parentheses 200 squared plus 12 times 200 plus 1400. And so I get 11,800 for this one. So 11,800. So then plugging in 500 should be a little easier because I can just copy paste. I can go up here and copy it, and everywhere there was a 200, I'm just going to change it to a 500. Going on over here, and I'll hit enter, and I get 79900. So 79900. So then throwing those into my slope formula, I'll have 79900 minus 11800 over 500 minus 200. And again, I can use my calculator here. So I'm going to have 79900 minus 11800. So on top I have 68,100, and that's going to be divided by 500 minus 200 is 300. And I get 227. 227. So the average rate of change is increasing by $227 per item. Okay. And then number 39 says, given this function, find the equation of the secant line. So that's an algebra question. So we're looking for y equals mx plus b, where our m is found using algebra. y2 minus y1 over x2 minus x1. So we're given the two x values, -7 and 15. I'm going to plug them into this function to find what the y values are. So f of -7 is -7 squared plus 6 times -7 plus 6. And I'll do the same thing for 15. And I get 15 squared plus 6 times 15 plus 6. And I can put these in my calculator. And so I'm going to have parentheses, -7 parentheses squared, plus 6 times negative 7 plus 6. And that one I get 13. So when x is negative 7, y is 13. And then I can just copy what I just did. And instead of negative 7, I'm going to put in 15. So 1, 5, 1, 5. And I get 321. So finding my slope, I'm going to have y2 minus y1 over x2 minus x1. So I have 321 minus 13, which is 308. So that's 308 over 15 plus 7 is 22. And we'll see what that gives us. 308 divided by 22 is 14. So that's my slope. And so right now I have y equals 14x plus b. So to find my b value, I pick either one of these points. I'm going to pick this point, and I'm going to put it in for my x and my y. So I have 13 equals 14 times negative 7 plus b. I'm going to multiply 14 times negative 7. And I get negative 98. So 13 equals negative 98 plus b. If I add 98 to both sides, then I'll have 111 equals b. So my equation is y equals 14x plus 111. That is my equation of a secant line. All right, number 40 says, given the function, find the equation of the tangent line. So we can find the equation of a tangent line by using our calculator. We are going to graph this right here in our y equals screen. So I'm going to go to y equals, hit clear, and negative x to the 6th power minus x squared plus 10x plus 6. And I'm just going to hit graph. And then once it graphs, I'm going to go to second program. So second PRGM. Choice number 5 is tangent. And then I need to tell it where. And it says that x equals 1. So I'm going to type 1, enter. And it draws it. And it says at the bottom y equals 1.99999. That's 2. So y equals 2x plus, and then 12.00000, that's 12. So y equals 2x plus 12. Okay. Then number 41. It says find the equation of the secant line. So a secant line is algebra. That requires 2 points. So I've got my 2x values here. X is 5 and x is 20. If I plug them in right here, I'll have the square root of 8 times 5 plus 9, which is the square root of 40 plus 9, which is 7. So when x is 5, y is 7. And then I'm going to put the 20 into that equation, and I'll get the square root of 8 times 20 plus 9, which is the square root of 160 plus 9, which you could type it in your calculator if you need to, but that would be 13. So y equals 13. So I have my 2 points going on. So finding my slope, I'm going to do y2 minus y1. And since I started with 13, I have to start with 20. So x2 minus x1. And that gives me 6 over 15. I can take a 3 out of both of those, and it gives me 2/5. So right now I have y equals 2/5 x plus b. To find my b value, I want to take either one of my points. I'm just going to take the smaller numbers, and I'm going to plug them in for x and y. So in for y, I'm going to plug in 7. And in for x, I'm going to plug in 5. Okay. And so you can type this in your calculator if you want to, but those 5's cancel. So we have 7 equals 2 plus b. Subtract 2, and we get 5 equals b. So my equation is going to be y equals 2/5 x plus 5. Okay, number 42 says find the equation of the line for y equals 3x plus 1 over 2 plus x squared at x equals 0. So this is a calculator problem. So we want to put this in our calculator and graph it. So I'm going to go to my calculator and clear out what's in there. Now, if you've got an old school calculator, you need to do parentheses, 3x plus 1 parentheses, like this. Close your parentheses, divided by parentheses, 2 plus x squared. And close your parentheses. Because you have to have your entire numerator in parentheses divided by your entire denominator in parentheses. If you have a newer calculator, you can do alpha y equals and choose number 1, which is numerator over denominator, and type in 3x plus 1 over 2 plus x squared. And I'm just going to hit graph. And my window's all kinds of whack, so I'm going to stop it by hitting the on key. And hit zoom 6, do a standard window here. Zoom 6, oh well, it's still thinking, isn't it? And once it graphs, I am going to go to second program. So I'm going to go to second PRGM, which is draw. Choice number 5 is tangent. And then I want to type in wherever my x is. So I want to do this at 0. So I'm going to type 0, enter. And it draws it. And at the bottom, it will tell me what my equation is. And I get y equals 1.49999, so that's 1.5 x plus 0.5. So I have y equals 1.5x equals 1.5x plus 0.5. And if it needs it to be in a fraction for whatever reason, you can math frac it on your calculator if you don't know these fractions. Awesome. All right, number 43. A company determines that the cost in dollars to manufacture X cases of DVDs entitled Students Who Secretly Love Math is given by C of X equals blah, blah, blah. Find the average rate of change. Average rate of change, that's algebra. So that is the slope between 2 points. So we'll be using m equals y2 minus y1 over x2 minus x1. Between 1 and 5 cases. So we have our two x values, 1 and 5. To find the y values, we're going to plug those back into our cost equation here. So C of 1 is going to give me 100 plus 15 times 1 minus 1 squared. So that's 115 minus 1, that's 114. And then if I put 5 in there, I will have 100 plus 15 times 5 minus 5 squared, which I'm going to type that into my calculator. So second quit, I have 100 plus, oops, I need another 0 there, plus 15, it doesn't like the numbers I'm typing, times 5 minus 5 squared. Enter. And that's 150. So once I have my 2 points, I can find my slope. So my slope is going to be y2 minus y1. And since I started with 150 first, I'll have to start with 5 first on my x's. So 5 minus 1. And so I have 150 minus 1, which is 36. And 5 minus 1 is 4. 36 divided by 4 is 9. So my average rate of change is 9, whatever I'm talking about, cases per whatever. Average rate of change. All right, then it says find the instantaneous rate of change. So the instantaneous rate of change is the derivative. So the instantaneous rate of change of cost with respect to the number of cases produced when just one case is produced. So I'm looking to find the derivative at just one case is produced. So f prime of 1, or I guess in this case, c prime of 1. The derivative evaluated at 1. And then it says, what about 3 cases? So I want the derivative evaluated at 3. And so I can use math 8 on my calculator for this. Math 8. And I'll put an x there. And then I'll put my equation in. 100 plus 15 x minus x squared. And this is for when x equals 1. Enter. And I get 13. So the instantaneous rate of change when 1 is produced is 13. And then the same thing, but for 3, I'm just going to go up and copy what I just did. So I'm going to arrow up and hit enter on that. And then I'm just going to go in and change the 1 to a 3. And I get 9. All right. Number 44 says, when using the limit definition of derivative to start finding the derivative, you will simplify as far as you can before foiling or finding a common denominator in the numerator. So using the limit definition of derivative. So I'm going to begin by writing it down. This is the limit as h approaches 0 of f of x plus h minus f of x over h. That is the limit definition of derivative. And it doesn't tell me at a certain value. It just wants me to start finding f prime of x. All right. And so that's what this is right here. So f prime of x, the derivative, equals what I'm doing right here. So I need to replace this part and this part. The f of x is actually what was given to me, so that's going to be easy. And the f of x plus h, I'm going to do that right now. So I'm going to have the limit as h goes to 0. Everywhere there's an x, I've got one there and there. Everywhere there's an x, I'm going to replace it with x plus h. So I've got negative 2. Instead of x squared, I have x plus h squared, plus 4, and instead of x, I have x plus h minus 6. So that's my yellow part. That's my yellow part. Everywhere there was an x, I replaced it with x plus h. Minus the blue part, which I'm going to put in parentheses. So minus negative 2x squared plus 4x minus 6. So that's the blue part. Okay, and that's all over h. So I'm going to keep going. Need to simplify a little bit. I'll have the limit as h goes to 0. So it's important to keep writing this until you actually plug in 0. This first part would require me to FOIL that right there. So I'm not going to do that. So I'm just going to rewrite that. So negative 2 times x plus h squared. Here I'm going to distribute that 4 through, and I get plus 4x plus 4h minus 6. And over here I'm going to distribute my negative sign through to the blue part, and I get plus 2x squared minus 4x plus 6. That's all over h. So I can cancel some of this. 4x minus 4x, negative 6, positive 6. And so what I have left is the limit as h goes to 0 of negative 2 times x plus h squared plus 4h plus 2x squared over h. And that's where I'm going to have to stop, because in order to go any further, I'd have to FOIL out the x plus h squared. And it says to stop right before FOILing or finding a common denominator. So that's where I would stop on that one. Number 45. Use the limit definition of derivative to start finding f prime of negative 4. All right, so I'm going to begin by writing the limit definition of derivative. The limit as h goes to 0 of f of x plus h minus f of x over h. And since this time it's given me a number to plug in, I'm going to plug in x equals negative 4 here. So I'll have the limit as h goes to 0 of f of negative 4 plus h minus f of negative 4 over h. So I had these two x values right there, and I replaced them both with negative 4 right there. Okay. Next I need to replace all of that, and I need to replace f of negative 4. Now f of negative 4 is pretty easy to find. I'm going to come up here and find it. This is where I need to put a negative 4 in for all my x's. So I have 3 times negative 4 squared minus 5 times negative 4 plus 9. And then I can type that into my calculator and see what that gives me. 3 times negative 4 squared minus 5 times negative 4 plus 9. And that gives me 77. So f of negative 4 is 77. So this part right here is going to be 77 when I get there. So I'm going to go ahead and write the limit as h goes to 0. For the green part, everywhere I have an x, I'm replacing it with negative 4 plus h. So I'm going to have 3, instead of x squared, I have negative 4 plus h squared. Minus 5, then I have negative 4 plus h plus 9. All right, so that's my green part. I replaced all my x's with negative 4 plus h. Minus the yellow part, which we just found earlier to be 77. All over h. Now I don't want to FOIL that out, but I can still distribute this right here. And so I'm going to have the limit as h goes to 0 of 3 times negative 4 plus h squared plus 20 minus 5h plus 9 minus 77 over h. I can combine 20 plus 9 minus 77 here. And so, see what that is. So 20 plus, oops, jokes, 20 plus 9 minus 77. And that gives me negative 48. So I have the limit as h goes to 0 of 3 times negative 4 plus h squared minus 5h. And then I just plugged those in and got minus 48. And that's all over h. And that's as far as I can go. Next thing I'd have to do would be FOIL that out. Okay, number 46. Use the limit definition of derivative to start finding f prime of 2. All right, so first thing I'm going to do is write the limit definition of derivative. The limit as h goes to 0 of f of x plus h minus f of x over h. And since it says at 2, I'm going to plug in x equals 2 here. So I'm going to have the limit as h goes to 0 of f of 2 plus h minus f of 2 over h. So I'm going to need to replace this green part and this yellow part. The yellow part, I'm just going to come over here and find. That's just f of 2. So everywhere there's an x, I'm going to put in a 2. And I get 16 over negative 2, which is negative 8. So this value right here is negative 8. So I'm going to have the limit as h goes to 0. For the green part, everywhere there's an x, which is one there and there, everywhere there's an x, I'm going to replace it with 2 plus h. So I'm going to have 8 times 2 plus h over, instead of x, I'll have 2 plus h minus 4. So that's the green part. Minus f of 2, which we said was negative 8. And that's all over h. So taking this a little further, I can multiply these through. So I'm going to have the limit as h goes to 0 of 16 plus 8h over, and here in the denominator, 2 minus 4 is negative 2 plus h. And right here I have a negative times a negative is plus 8 over h. And that's as far as I can go without having to get a common denominator in the numerator. So that's where I will stop on this problem. So number 47, use the limit definition of derivative to start finding f prime of negative 5. So that's the derivative at negative 5. So I'm going to start by writing the limit definition of derivative, which is the limit as h approaches 0 of f of x plus h minus f of x over h. Since it says to do this for f prime of negative 5, I'm going to go ahead and plug in x equals negative 5. So I'm going to have the limit as h goes to 0 of f of negative 5 plus h minus f of negative 5 over h. So I'm going to need to find this green part here minus this yellow part. The yellow part I'll go ahead and find. So the yellow part, I'm just looking for f of negative 5. So everywhere there's an x, I'm going to replace it with negative 5 to the third plus 3 times negative 5. That I can type in my calculator, and I'll get 2 times negative 5 to the third plus 3 times negative 5. And that gives me negative 265. So this number right here is going to be negative 265. So I'm going to have the limit as h goes to 0. For the green part, everywhere there's an x, I'm going to replace it with negative 5 plus h. So I'm going to have 2 times negative 5 plus h to the third plus 3 times negative 5 plus h. So that's my green part. Minus the yellow part, f of negative 5, which we said was negative 265, all over h. Now I can distribute this right here, and that would become minus 15 plus 3h. So I'm going to not worry about that. And here a negative times a negative is plus 265. And so I have the limit as h goes to 0 of 2 times negative 5 plus h cubed. I can combine negative 15 plus 265, and that gives me plus 250 plus 3h, and that's all over h. But that's as far as I can go without having to start foiling out this term right here. Okay, number 48. Use the limit definition of derivative to start finding f prime of 3. So I'm going to write the limit definition of derivative. The limit as h goes to 0 of f of x plus h minus f of x over h. And since it says an x value, I'm going to plug in x equals 3. So I'll have the limit as h goes to 0 of f of 3 plus h minus f of 3 over h. So I'm going to need to replace that green term and this yellow term. For the yellow term, I'm going to come over here and I'm finding f of 3. So everywhere there's an x, I'm replacing it with a 3. And so I have 12 minus 5 on top, which is 7, and 6 minus 3 on bottom, which is 3. So this term right here is going to be 7/3. For the green term, everywhere there's an x, and there's 2 of them, I'm going to replace it with 3 plus h. So I'm going to have the limit as h goes to 0. 4, instead of 4x, I'm going to have 4 times 3 plus h minus 5 over 6 minus, and in parentheses, I'm going to put 3 plus h. So that's the green part. Minus this yellow part, which we said was 7/3. And that's all over h. So I can distribute right there, and I'll have the limit as h goes to 0 of 12 plus 4h minus 5 over 6. Right here I can distribute the negative sign. Minus 3 minus h minus 7/3 over h. And the last thing I can do is combine some terms. So the limit as h goes to 0, 12 minus 5 is 7 plus 4h over 6 minus 3 is 3 minus h minus 7/3 over h. And that's as far as I can go without getting a common denominator in the numerator. All right, number 49. Use the limit definition of derivative to start finding f prime of -1. So I'm going to write the limit definition of derivative. The limit as h goes to 0 of f of x plus h minus f of x all over h. And this is for f prime of -1. So I'm going to go ahead and plug in x equals -1 right here. So I'll have the limit as h goes to 0 of f of -1 plus h minus f of -1 all over h. So I'm going to need to replace this green part and also this yellow part. I'm going to come over here and find the yellow part. That's going to be f of -1. So everywhere there's an x, I'm going to replace it with -1. And so in the numerator, I have 8 plus 3 is 11. And the denominator, -1 plus 2 is 1. So that's just 11. So this term is going to be 11. So I'm going to have the limit as h goes to 0. Everywhere there's an x, I'm replacing it with -1 plus h. So 8 minus 3 times -1 plus h over -1 plus h plus 2. That's my green part. Minus the yellow part, which was 11, over h. All right. And I can distribute that term through, so I'll have the limit as h goes to 0 of 8. -3 times -1 is plus 3 minus 3h over. I can combine -1 plus 2 is 1 plus h. And then it's minus 11 over h. The only thing I'm left to combine is I can combine that 8 and 3 right there. So I'll have the limit as h goes to 0 of 11 minus 3h over 1 plus h minus 11 all over h. And that's as far as I can go without getting a common denominator. All right, number 50 says, for the graph below, find all values of x where the function is not differentiable. So not differentiable means it does not have a derivative. Does not have a derivative. So there are 3 things to look for. If the graph at any time goes vertical, then it would not have a derivative there, but that doesn't happen on this graph. The other 2 places are wherever it's discontinuous, like there's a hole or a gap in the graph, or if there's a sharp corner, which happens right there. So reading left to right, the first place we have an issue is at -5 because we have discontinuous there. There's a hole in the graph. So at x equals -5, there's no derivative. The next place would be right here where there's a sharp corner, and that happens at -2. And then the next place would be where it's a gap in the graph right there at 1. So there are 3 places where this function is not differentiable.